Okay, so the next thing we're going to learn about now is something called a conjugate, okay? And why it might be useful when we are trying to simplify radical expressions. So right here, this in black might be something that you'll see in a problem. And the red right here is considered the conjugate. Notice how it's almost identical, okay? First and second term are the same. However, that middle sign, that sign is different, okay? I like to refer to these as evil twins. Oh, my goodness. Whew. Don't worry, conjugates aren't as scary as these girls. So, the reason I like to think of them as evil twins is because they're basically the same like twins. However, they have different signs. So if this was negative, the conjugate would be a positive sign in the middle, and vice versa, okay? So, the reason that conjugates are useful is because when you multiply something by its conjugate, what happens is the result will get rid of any radical that was present, okay? So one reason that this might be useful is if we have a binomial with a radical in our denominator, we can go ahead and multiply by the conjugate if we wanted to go ahead and clear out that radical, okay? So let's go ahead, we're going to multiply and FOIL these together just to see what the end result would be, and then we'll do a problem where we actually have it in a fraction in the denominator and see how we use it. So let's go ahead and multiply this together, see what we get. All right, so if we remember for FOIL, first we have to go ahead and do f times f, or I'm sorry, first one's first. So 6 times 6 gets us 36. Outside, 6 times negative root 2, so negative 2 root 6. Inside would be plus, sorry, I meant 6 root 2. Take that back. Negative 6 root 2, and right here would be plus 6 root 2, and then we would have a positive 2 times a root 2 times a negative root 2, which gets us root 2 times root 2 is just 2, so minus 2. Okay? You'll notice that the middle two terms, the O and the I in FOIL, will cancel out. This will always happen with conjugates. Okay? When you're multiplying two conjugates together, the O and the I will cancel out. So here we go, cross that out. What are we left with but 36 minus 2, which is just 34. Okay, so once again, I'm going to repeat. When multiplying two conjugates together, or something by its conjugate, the middle two terms will always cancel out. So therefore, we don't even have to do that part of FOIL. When multiplying conjugates together, all you have to do is the first times the last. That's it, okay? So with conjugates, like I said, it's not as scary as our twins. So let's go ahead and see what a problem actually would look like where we might want to multiply by a conjugate. Okay, so this is number 1 on page 24. So let's go ahead and see. So right here in the denominator, we have 3 plus root 5. We have a binomial with a radical present, okay? We can't just multiply by root 5 like we could do before when it was just a monomial in the denominator. So let's go ahead and try multiplying by the conjugate. So in this case, the conjugate would be 3 minus root 5. And we have to do it on the top as well, so we keep an equivalent fraction. Okay, so let's take care of the top first because it'll be the easier one to do. So we just distribute. 3 times 2 is 6 minus 2 root 5. Let's go ahead and take care of the denominator now. Remember, we would have to FOIL these two together. However, the O and the I will cancel out, okay? This is technically like a difference of squares, or it is a difference of squares. So let's go ahead and multiply it together. So the first times first would be 3 times 3, which is 9. And then last, it's going to be a minus sign because one's negative. Root 5 times root 5 we know is root 25, or just 5. Okay? Simplify that denominator. 9 minus 5, we get 4. Okay, a lot of you might want to leave it right here. There is one last thing. You should look for, if all of your coefficients, so both the front of the subtraction sign and in back, as well as the denominator, if they can all be simplified, so in this case divided by 2, then you can go ahead and do that. So our final answer in this problem will be 3 minus root 5 all over 2. Okay, so that's how conjugates work. Again, just to recap. If you have a binomial in your denominator with a radical present, you want to go ahead and multiply by the conjugate, or its evil twin, okay? Where the only thing that changes is that middle term. It's going to clear out your radical, okay? And leave you with a fully simplified answer. Okay, so that's it. That's conjugates.